Now let's talk about factoring a trigonometric equation or expression using the same function. Now, this is useful for being able to prove identities. This is going to be useful when it comes to simplification, but this is also going to be used to when we actually start to solve trigonometric equations. So let's just look at a couple of things and see that they work exactly like any other type of thing that we might be factoring. It looks a little bit scary because now we're talking about secants and cosecants and things like that, but in reality, it's going to act the same way. So if I'm going to factor secant squared of x minus 1, well, I notice that this is something squared minus something squared. So, because remember, I can write 1 as 1 squared. So this tells me that I have a difference of squares. And this is going to be factored into u plus k and u minus k. So in this case, my u is going to be secant, and my k is going to be 1. So I can rewrite this as secant of x minus 1 and secant of x plus 1. So if we have something that's a difference of squares, if we have something that's a difference of cubes, an addition of cubes, all of those things are still going to be factored in the same way. And that's true for our second example down here. If we have 4 tangent squared of x plus tangent of x minus 3, I can kind of substitute. If it helps you to see, this is not a required step, but for some people it does really help to notice that this is actually just a binomial, or not a binomial, this is just a quadratic. So we get 4u squared plus u minus 3, because as long as I substitute tangent for u, I'm getting this quadratic. And from here, I can solve this several different ways. I can use the quadratic formula to factor this. I can use my rational zeros theorem to factor this, or I can use what we call, or what is typically called the AC method to factor this. And what this is going to give me is 4u minus 3 and u plus 1, or 4 tangent of x minus 3 tangent of x plus 1, because I'm just going to plug that u back in for tangent when I'm at the end. So when it comes to factoring these, you can do factoring by grouping, you can do simple quadratic factoring, you can do difference of squares, you can do any of those types that we have. As long as you have those skills to be able to factor them, they're still going to factor in the same way. So again, if we get to something that is maybe a cubed up here and we aren't able to factor it by grouping, we can always use that rational zeros theorem that you would have learned, again, back in the algebra portion, to be able to factor this out into the real portions. Now, that means that we can also use polynomial division and synthetic division here, so kind of keep watch out for that.